Welcome to our lesson on solving two-step equations. Now, if I were to ask you to make a drawing using positive and negative chips and some mystery envelopes to try to show this equation and solve, let's go ahead and read the equation first. It says 3x minus 4 equals 8. Now, the mystery envelopes would be represented for the 3x because we would have 3 mysterious envelopes. We don't know how much is in each one. And then we have minus 4. So I'm going to put 4 negative chips or 4 red ones. Okay, now this part of the equation says 3x minus 4 equals, so I'm going to do a big huge equal sign so that you don't get it confused with the negative chips, and make sure you're drawing this along with me, equals positive 8. So now I'm going to go ahead on the right hand side of my equation and I'm going to draw 8 positives. Okay, now when I look at an equation, I need to think of it as kind of like a balance. If I do something to one side, I'm going to do something to the other side. Now, the most logical thing that I could think of to do right now would be to add, because of course my goal here is to get x alone. So if I add 4 positives to this side, it starts to get x alone because those are going to cancel out. But if I add 4 positives to the left side of an equation, I have to add 4 positives to the right side of an equation. So now that all cancels out. And what I'm left with is 3 mystery envelopes of x and an equal sign. And then now I have 12 over here because I had 8 and then I needed to add on 4. And so what I can do, if I want to know what x is, just x alone, 1x, I see that x would be 4 because that x is 4, that x is 4, and that x is 4. Now let's go ahead and check that. We think x is 4, but x is only 4 if it makes the equation true. So let's go ahead and check. 3 times 4 minus 4 should equal 8. I would do 3 times 4 first, which is 12, minus 4, which does equal 8. So that's also how I would check my work. Okay, so if I just look at the equation, of course I'm not going to draw a picture every single time. But I'm going to instead use something that I like to call SADMEG. SADMEG is basically a way that I can remember the order of how to solve an equation in. And I like to just kind of draw a little picture of a girl named Meg, and she is crying because she wants to get the x value alone. Okay, so let's go ahead and use SADMEG. Subtract or add would be first. Anything subtraction and adding. This is because the subtraction and addition is kind of just hanging off the side over there. Okay, so to get rid of subtraction, we always add. So I'm going to add 4 to this side and add 4 to this side. Minus 4 plus 4, or you could think of it as negative 4, positive 4, cancels out. I'm left with 3x equals 8 plus 4, which is 12. Then I can do my multiplication division, which would be dividing by 3, because the inverse of multiplication is division. And again, make sure you're showing all of that work. Your work needs to look identical to mine. Now, when you first look at an equation, you're going to get rid of the one that's kind of hanging off at the edge. And then, after that, you can get rid of the number that's kind of connected, hanging on to x. These two are sort of connected here. This one's hanging off, so we're going to do that one first. Okay, you might want to pause the video for a moment because this is something you need to write out. These are the key concepts for solving two-step equations. Step 1, you're going to undo subtraction or addition first. Step 2, you'll undo multiplication or division second. And then step 3, you're going to undo the exponents or grouping symbols if there are any. Now, we're not going to be doing anything with exponents or grouping symbols yet, but later this unit we will. So, this order, SADMEG, subtract or add, multiply, divide, exponents, grouping, it reminds us of the opposite of order of operations. The opposite of order of operations. Now you can remember that our order of operations was GEMDAS, grouping, exponents, divide, multiply, add, and subtract. But now we're going to reverse that in order to get x alone. Okay, so let's go ahead and try it. Go ahead and write out this problem. 6x plus 2 equals negative 10. The very first thing I'm going to do is scan my problem to see if there's anything I could add or subtract. And in fact, there is. I can subtract 2 because 2 minus 2 would cancel out. So I want you to write that out as your work, and I also want you to slash it off to show that it's no longer there. Now, what I currently have is 6x equals negative 10 because negative 10 minus 2 is negative 12. And if you needed to kind of do that on the side, negative 10 minus 2, you would do a leave change opposite and see that it does actually equal negative 12. Okay, now the next thing I need to do is get x alone. Currently it's being multiplied by 6. So to reverse that, I would divide both sides by 6. 6 divided by 6, oops, sorry about that. 6 divided by 6 is 1. So I'm now left with 1x equals negative 12 divided by 6 is negative 2. Now let's go ahead and check our work. So we're going to plug it back in. I'm going to show my check mark, my check mark sign to make sure that I know that I'm checking my work over here. 6 times, instead of x, I'm going to say times negative 2, plus 2 should equal negative 10. If it doesn't, I know I have the wrong answer and I'll start again. 6 times negative 2 is negative 12, plus 2 equals negative 10. Negative 12 plus negative 2 is, in fact, negative 10. So here we have it, negative 10 equals negative 10. That is true. Now, when you're solving a two-step equation, you can think of it like this. You need to combine the whole numbers first, and then the variables come last. Okay, one more thing I want to point out is our properties of equality that we used from our previous video a couple days ago. The property of equality that we used right here, we had subtracted 2 from both sides, so that is the subtraction property of equality. As long as I subtract the same number from both sides, it's going to stay equal. Now right here, you can see that I had divided both sides by 6. And so that is the division property of equality. Okay, on to our next problem. Let's go ahead and do the first one together, and then you can try the next two by yourself. So in the very first problem, I'm going to scan it and see what's going on. I see that y is being multiplied by 2, and it's also being subtracted by 0.3. So the very first thing I'm going to do is get rid of the subtraction. Again, I'm going in reverse order of operations. I'm going to go through SADMEG. I see a subtract or add I could get rid of. It's minus 0.3 right now. To do the inverse of that, to reverse it, I'm going to add 0.3 over here and add 0.3 over here. Now, positive negative 0.3 is going to cancel off, and then I have 0.7 plus 0.3, which is 1. 1 equals 2y. Now, y is being multiplied by 2, so I'm going to divide by 2. But here's the thing. We talked last week. If I give you decimals in the problem, you have to give me decimals as an answer. So we're going to go ahead and convert this to 0.5 equals y. And again, because of my properties of equality, I want to keep everything coming straight down. I don't want to flip it and say y equals 0.5 or anything like that. Okay, let's go ahead and check our answer. 0.7 should equal 2 times 0.5 minus 0.3. Okay, 0.7 equals 2 times a half is 1 minus 0.3, and I do see that it actually is equivalent. Okay, go ahead and press pause on the video and try the next two problems on your own. Once you're done, we'll go over them together. All right, hopefully you got the same answer as I did for this second example. The SADMEG tells me to scan for anything that would be subtract or add, and I do see minus 15. So what I'm going to do to reverse that is I'm going to add 15 to both sides, again, to keep it equal, addition property of equality. Minus 15 plus 15 cancels out, and I'm now left with x divided by 9 equals, 27. Okay, the next thing I'm going to do, x is being divided by 9 right now. In order to do the inverse or reverse that, I'm going to go ahead and multiply this side by 9 and multiply this side by 9. 9 divided by 9, or 9 over 1 times x over 9 is going to be just 1. It cancels out. It would cross-reduce if I made it my fraction. So x equals 243. And if you go in and plug that in and check it, it does work because 243 divided by 9 is 27. And then when we subtract 27 minus 15, we do get 12. So this would work. 12 will equal 12. Okay, last example. The very first thing I'm going to do is subtract 15 from both sides. Then I'm left with 3/5 x equals negative 3 minus 15. That would be a leaf change opposite. I've got 3 negatives and 15 more negatives. That's negative 18. If you think back to the first example we did with the chips, you'll remember that this visually would look like 3 negatives and then 15 more negatives, which is 18. Okay, this next part is a little bit tricky. We're not going to divide because we don't divide fractions. Instead, we multiply by the reciprocal. So I'm going to multiply by 5/3 over here, and I'm going to multiply by 5/3 over here. And I can look for cross-reducing, which is definitely a possibility here. These can reduce to a 1 and a 6, but remember it's actually a negative 6. So 5/3 times 3/5, those cancel out. Anything times its reciprocal is 1. So it's just going to say x equals negative 30. Okay, if you plug that back in, it will work. 3/5, oops, sorry about that, times negative 30 over 1 plus 15 will equal negative 3. These would cancel off, and it would say negative 18 plus 15 equals negative 3, and we do know that that is true. Okay, next slide. Oops, sorry about that. The multiplication property of negative 1. So we talked about this a little already, but this is the same sort of situation. We're going to use SAD, neg, subtract, or add. So the very first thing that I'm going to do here is subtract both sides by 6. And then once you show that on your paper, remember you're writing this out with me, 6 minus 6 is 0. So that cancels, and I want you to show that it cancels. That was the subtraction property of equality because I was subtracting the same number on both sides, which keeps it equivalent. Okay, from here, if I subtract 6 minus 6, that's 0, so I'm left with negative b equals negative 17. Now, negative b is really the same as negative 1b. So in order to get b alone, what I'm going to do is I'm going to show that I'm dividing both sides by negative 1. That's my division property of equality. And then I'm left with b equals 17 because as we know, negative divided by, oops, sorry about that. Negative divided by a negative is always a positive. So those cancel off and we're left with b equals 17. And of course we can plug that in. Negative 17 plus 6 would equal negative 11. Okay, and our final slide for right now, I want you to do the first one with me, and then you could try the second one on your own. So, very first step, I'm going to subtract 3/5 from both sides. Now, I know that that would be a difficult thing to do because I've got a mixed number right there. So the first thing I'm going to do is make this improper. 2 times 5 is 10, plus 1 is 11. So it's negative 11/5 minus 3/5, and I got the minus 3/5 from right there. These canceled out. Now I'm left with negative d equals, I'm going to leave change opposite, negative 14 over 5. And the last thing I'm going to do is divide by negative 1. And I'm left with d equals 14 over 5. And if you check that, it does in fact work because 14 over 5 plus 3/5 would be negative 11/5, which is negative 2 1/5. Okay, last one, we're going to go ahead and pause and try it on your own. All right, hopefully you got the same answer as I did. The very first thing you want to do is subtract 7.5 from both sides. Now, when you go to set that up as a math problem, remember we subtract like normal. This is obviously a small number minus a big number. So we're going to get a negative answer. So I'm going to drop my negative sign in right now. But when we actually go to do the math, we do it normal math, which means the bigger number goes on top. Or the number with the greater absolute value. So this is going to become a 4 and a 10. 10 minus 3 is 7. 4 minus 2 is 2. And then 7 minus 1 is 6. So this is negative 6.27 equals negative y. And the very next thing I'm going to do is divide both sides by negative 1. And I'm left with 6.27 equals y. Okay, the last thing that I want you to do is solve this and explain in 1 or 2 sentences. We will go over that first thing tomorrow. Thanks for watching.